Source control. Okay, so you're a software developer. I'm going to assume that you use source code control software, because the last programmer stubborn enough not to use source control died in 2008. However, in the off chance that you are too young or too old to know the gospel, I'm going to give a very brief overview of what you somehow managed to miss. A project composed of code has three problems that source code is designed to solve: history, collaboration, and branching. History. A complex edit to your codebase is going to involve small or large changes to several different files at the same time. Let's imagine, though, that your changes don't work. You've changed several files and now you need to change them back to the way that they were before. Or the change did work, but there was something important in the code that you deleted, and now you need to look at it again. You could frantically jam on the undo command until your code is the way it was when it last worked. The obvious problem with this is that you have to remember exactly how the code looked when it worked last, and you have to keep all of your code open in the same editor for as long as you're editing it, and you have to trust that your editor has a long undo history. Or you could selectively comment out patches of code that you think might be useful again in the future. This is called the lava flow anti-pattern, so named because you develop a thin stream of live code surrounded by layers and layers of cold, old, inoperable code. It's messy, it's incomplete, and these commented out blocks reproduce if you leave them alone too long. Soon you have more commented out code than real code. So, source code control allows you to set checkpoints whenever you like, and you can go back to these checkpoints anytime that you want. Collaboration. Once you introduce a second person into your code modification process, you've introduced a raft of potential difficulties. How do you keep updates synced up between computers? If you happen to be able to work with a persistent internet connection, you could have a few people working on the same network share, implementing a complex system of semaphores to keep people working on the same file at the same time from colliding with one another. Or you could just make diffs of all of your changes and email them to a central code manager. Okay, at this point you might be getting wise to my rhetorical strategy of sarcastically presenting awful solutions to complex problems. These are awful solutions. Source code control always comes with some kind of usable collaboration strategy. We'll talk more about that later. Branching. Finally, it's possible that you might want to maintain different states of the codebase. For example, you might want to maintain a deployed version of your code as well as a development version. Most modern source control solutions support branching, which allows you to maintain separate states of your codebase in parallel. Backup. I want to make this clear. Version control software is not backup software. A software repository is not a backup. It's something to back up. However, if your team has all of its code in one place, you at least have something concrete to back up. Okay, so history, collaboration, and branching. Even if you're just working on your own code, if what you're working on is more complicated than a tiny script, you're probably going to want source control. The history features alone make it worthwhile. Perhaps the single most useful feature of source control is seeing what changes you've made since the last time you committed. Source control options. I'm going to focus mostly on Subversion, Perforce, and Git in this presentation because they cover a lot of ground in terms of different types of features, and because they're the options that I'm the most familiar with. Of these, Perforce is proprietary software, and Subversion and Git are open source. Collaboration models. Imagine that you have two people, Mark Peters and Captain Magic, each working on the same repository and each wanting to edit the same file. There are two ways that source control traditionally resolves this issue: lock and edit merge. Lock and edit. Captain Magic locks the files that he wants to edit. Nobody else can edit these files until Captain Magic finishes with them. Perforce works this way. Edit and merge. Captain Magic and Mark Peters both edit the same file at the same time. Captain Magic completes his change and commits it to the server. Before Mark Peters can commit his change, he has to download Captain Magic's change and merge both changes together. If they were both editing different portions of the file, this merge can be completely automatic. But if they both change the same lines in the file, they'll have to resolve the merge manually. Subversion and Git both work this way. Both lock and edit and merge are usable and useful collaboration models. Edit and merge, the subversion way, is considered to be a little friendlier for collaboration. It's possible for people to work on any file that they like without worrying about locking something that another developer needs. But some developers find the automatic merge behavior troubling. Centralized versus distributed. Perforce and Subversion are both centralized repositories. One canonical server contains the entire history of the codebase. You check out a set of files from the repo, work on it for a while, and save your changes back to the repository. Git is a distributed repository. You'll probably still have a central server with a master repository for the sake of clear collaboration, but this isn't mandatory. Each individual developer also has their entire repository on their machine. They check out changes from their personal repository, work on them, save them back to their personal repository, and then sync their personal repository with the master repository. Both schemes have their ups and downs. Centralized repositories are decidedly less complicated, and in the case of very large repositories or very long histories, it can be useful for developers only to have to deal with a small subset at any given time. However, this means that all repository operations have to go through the network to the central server. If you want to see the differences between your file and that same file a version ago, that's a network request. Every time you make a major change to the codebase and commit it, that's another network request. I once worked at a big tech company. I don't want to be too specific, but they made a cell phone named after a fruit, not the fruit you're thinking of. And the entire company did all of its development on one enormous Perforce repository. Every product, every version, every peripheral binary, all loaded into the same giant repository. And even though that one repo was hosted on a pretty mighty computer around 9 o'clock in the morning and around 5 o'clock in the evening, it started to get really, really slow. With distributed repositories, operations against the repo are local and fast. Distributed repositories are extra great if you happen to be working in an area with network difficulties, like a bus, or 2 buses. Revision numbers. One important facet of version control systems is how they identify files over time. Let's look at a repository containing 5 files. As we change these files, how do we keep track of the different versions of the file over time? Subversion, Perforce, and Git all handle this in different ways. In Perforce, each individual file has its own revision number. Every time you change a group of files, each file's revision number increments, but files that aren't touched don't change. In Subversion, the entire repository gets a revision number. Every time you change a group of files, the revision number of the entire repository is incremented. In Git, thanks to the fact that it's distributed, using an incrementing number for versions is a no-go. If Mark Peters and Captain Magic both make a change to the repository, and later these changes are merged together, who is to decide which one of these changes came first? Instead, Git gives every change a unique hash value. Traditionally, the most recent change is known as the head revision, although in Perforce, every file has its own head revision. Other VCSs. I've talked to you about Perforce, Git, and Subversion, but I might as well quickly mention some of the others that you might encounter, keeping in mind that I probably know less about them than you do. You're unlikely to ever encounter SCCS, the first version control system, or RCS, its successor, but you might encounter CVS, Subversion's predecessor, and one of the most popular source control systems for almost 20 years. Visual SourceSafe, a defunct Microsoft technology, has a reputation for data corruption and broken hearts. There's Team Foundation Server, a Microsoft technology and successor to the dubious legacy of Visual SourceSafe. It's a version control system with a hefty dose of bug tracker, build server, and project manager packed into one big integrated solution that works really well if you're using Visual Studio and an all Microsoft stack, and, well, if you're not, then maybe not. There's Mercurial, or HUG, a lot like Git, but considered by many to be easier to use and written in Python, which is a nice bonus, and Bazaar, which is Windows native and focuses on a clean UI and easily understood merges. Conclusion: use source control. Thanks for watching.